In this video, we demonstrate how tabular data can be prepared and enriched in a compliance-aware way with the new functionalities currently being developed within the SemT X framework. Starting from a GDPR compliance check, we show how critical elements in the data can be identified and how enrichment functionalities can be used to transform the data into a GDPR-compliant and analysis-ready form. To illustrate this, we consider a simple use case based on data available in the GATE data space, aimed at studying students' exposure to air pollutants in the areas surrounding their homes and schools. We will start by demonstrating how to make a table containing student enrollment data GDPR compliant, and then how to prepare air quality data collected across different monitoring periods using enrichment functionalities to make them homogeneous. In particular, we will focus on how meteorological data can be integrated by relying on an external service. Let's take a table of kindergarten enrollment data and show how we perform a compliance check, pseudonymize the child ID column, and generalize the permanent address, removing the original columns to make the table GDPR compliant. First, we perform a GDPR compliance check on the table by clicking on the respective button, and we specify the purpose of data preprocessing, and then we click on Check Compliance. As we can see from the report of the column analysis, we need to pseudonymize the child ID column and generalize the permanent address column. Let's start with the child ID column. We select the column, click on the Modify button, choose the pseudo-anonymization, and confirm, obtaining the child ID _anonymized. Next, we can proceed with the permanent address column. In this case, we need to generalize the geographical coordinates by keeping only 2 decimals, which corresponds to the kilometer scale. First, select the column, click on the Reconcile button, and choose Geo Coordinates as service group, and then the Here option, and confirm. To view its geographical coordinates, we can expand the column by clicking on the respective button. Now, we can extend the column and choose Annotation Properties Service to extract IDs, obtaining a new column. We select the column, click on the Modify button, and choose Regular Expression Modifier. As we can see from the example, we can use the following pattern to extract numbers with up to 2 decimal. So we select the Extract All Matches option, specify the pattern and the name of the new column as Permanent Address Generalized. Now we can save and perform a GDPR compliance check on the current table to verify if the new columns resolve the non-compliance. As we can see, the new report confirms that these actions meet the anonymization criteria. Finally, we can delete the following columns: ID _ permanent address, birth year, and child ID. Save the table and conclude with another GDPR compliance check, obtaining a table GDPR compliant. For the second part of the demo, we work with air quality data, enriching the dataset with weather information from an external service. We first reconcile stations to geo-coordinates and format timestamps to ISO 8601 as required by the Weather API. Different data providers record air quality in different ways, so the datasets are not homogeneous. While we cannot alter the air quality measurements themselves, we can enrich them with meteorological data from an external service. Now we'll show how to do this with a sample of the first table. As we can see from the table, there is no column regarding precipitation, so we can proceed in extracting it by searching for an appropriate extender. We can click on the question mark button and then Discover Services. We can see that in the extension section we have Meteo Properties Open Meteo that accepts in input a column reconciled with its geographical coordinates and a second column containing date values in ISO 8601 format to extract hourly parameters such as precipitation. Going back to the table, we can first automatically annotate the schema, choosing the LLM column classifier service. As we can see, the station column is now annotated as named entity E and the others as literal L, since they contain air quality measurements. We can select a cell of the station column and reconcile it with its latitude and longitude that are known. We click on Add Metadata and select as prefix geoors for geocoding here service and paste the coordinates and specify the name. Then we click on Add and Confirm and Propagate to propagate the metadata to all cells with the same value in the entire column, and confirm again. To verify, we can expand the column by clicking the Expand button to view its coordinates. Now we can convert the date values of the timestamp column by selecting the column, click on Modify, and choose the Date Formatter option. Then we select the ISO 8601 format and specify the level of detail with hour and minutes, and confirm. Finally, we are ready to extend the station column. First, we select the column, click on Extend, and choose the Medio Properties, Open Medio option. As we can see, we need to specify the column containing dates values, which is the timestamp column, and choose hourly parameters to select precipitation, and then confirm, obtaining a new column for precipitation. In this last part, we show how the designed enrichment steps can be exported as a Python notebook and reused in a Jupyter environment to process other tables with the same schema. Since we worked on a sample, the same enrichment can now be applied to the full table or to future tables from the same data provider. This approach supports reusability, automation, and scalability of data preparation workflows. With SemT X, enrichment pipelines can be generated as notebooks for interactive execution or as Python scripts for batch processing, which can then be further engineered into at-scale workflows, running in environments such as Airflow or Argo. Going back to SemT X, we save the table and export the pipeline as Jupyter Notebook Pipeline. Now switching on Jupyter, we can open it and view the operation summary with the propagation of the metadata on column station, modification on column timestamp using date formatter, and extension on column station using Medio Properties, Open Medio. Thank you for watching.